다음 연사를 발표하겠습니다. Cryptium Labs의 founder Adrian Brink 님께서 Protocol Engineering, Making Blockchains Work라는 주제로 발표해 주시겠습니다. 큰 박수 부탁드리겠습니다.
Cool. Hey guys. Good morning. Thank you very much for coming to the relatively early sessions. So today I'm going to sort of take the next 20-25 minutes to talk about core protocol engineering, making blockchains work, and sort of why this is an important topic that is often underappreciated. And because I think generally speaking, sort of the people building the applications on top tend to get a lot more press, right? And I'll have a bunch of examples about this later. But this talk is very much about core protocol engineering. And I'd like to start off, maybe actually with a little bit of background. So I'm Adrian. I am one of the founders of Cryptium Labs. We are a bunch of protocol engineers that like to sort of do research into decentralized applications and take that research and implement it into like production-ready systems. Right now completely blockchain agnostic. So we are we also happen to run a validator. This is mostly historic path dependence. We started with a validator, but turns out that we like running the protocol, developing the protocols more, and so we run validators on things that we find technically interesting. To start off with, what is core protocol engineering? It is everything that very few people talk about. So it's a consensus system, it's a proof-of-stake implementations, it's how efficient your light clients are, it's how efficient your database implementations are, how efficient your hash functions are. It's not sort of what is the user-facing application that people build on top of this. So like the basic example in Ethereum, it's sort of how efficient is the virtual machine, or how efficient is Solidity, what kind of opcodes exist in Solidity, and not so much, let's try and build a prediction market on top of Ethereum in a smart contract. So yeah, this is what I'm going to talk about the next 20 minutes. I hope you're in the right room, and you will enjoy the talk. Cool, so let's quickly start off by this. Why does this actually matter? And sort of, to me, the most telling example here is, again, Ethereum, because Ethereum has been around for a long time, and we sort of had a chance to see what happens there. So Ethereum was very, very good at figuring out a business model for application development, for dApp development, right? Sort of in the last 3 years, with the ICO and fundraising boom, Ethereum dApps roughly raised about $4 billion, which is a staggering amount, right? And sort of looking at what actually came out of it, a bunch of pretty presentations and very little actual usage, but there's a reason why there's very little actual usage. It's not because the idea sucked, it's because we spent about $4 billion in funding cool applications on top, and almost zero money on funding the people that like extended the underlying core protocol. So Ethereum sort of, they took off in this trajectory where application development took off massively, but at the same time they didn't figure out the business model for core development to happen, and so everyone sort of was left in this effectively prototype stage. Sure, it changed a little bit over time, but like it didn't, the pace of the underlying engineering for Ethereum didn't keep up with the demand on sort of the application side. And this sort of resulted in a bunch of other projects launching afterwards. But this is really fundamentally why core protocol engineering matters, and why any chain that is sort of thinking about this today really has to think not only how do we incentivize people to build on top of us, but how do we incentivize people to build the chain itself. Because if no one builds the chain, you end up in a situation where CryptoKitties halts your chain for 3 weeks, and afterwards everyone goes like, well, this is really difficult to change, no one worked on this for years. Come back in like 3 once we have like ETH 2.0 working. So this being one of the examples. Oh, and so the most staggering examples is like the $4 billion that got funded for dApps. Parity, which is arguably one of the main client implementers for Ethereum, received in the same time frame roughly $4 million to actually maintain the underlying infrastructure. Just sort of like the order of magnitude and difference in the funding is staggering to me. Yeah, so this is sort of why this really matters. Cool. So now that we sort of spoke a little bit about why protocol engineering is actually really important, it is also important to acknowledge that currently there's about 2,000 or so like unique individual assets. Not all of them try to be their own thing. Some of them are dApps, some of them try to be their own chain. But realistically, most of them will go away. Like, I don't see a future in which we have 2,000 independent chains that sort of like happily sit there and like do their own little niche thing. The more likely scenario here is that we end up in a system where we probably have a couple of large ones, so we maybe have like 5, 10, 20, but sort of in that range of size, really. And so for protocols, for blockchains, the question is really, given that there's a blockchain war coming and sort of not everyone will make it and most people will actually fail, how do you differentiate yourself? How do you compete with each other in this aspect? And I don't necessarily mean this even in competition between, for example, Bitcoin and Ethereum. I think they can happily coexist. Also, Cosmos, Tezos, Polkadot, they can most likely all happily coexist. I'm not too worried about this, but it's really about how do you compete against everything else that's out there in the world. And one of the important points here, so there are sort of two fundamental theses for this, on how do you outcompete the rest of the world. One of them being systems without governance are very likely to fail in the long run. Mostly because systems without governance do not provide a clear path to developers such as myself, core devs that like to work on protocols, to sort of go, well, this is the current state of things, and I have an idea, so I'll tell the community about my idea, and then the community goes like, yeah, this seems reasonable, show us a prototype, and I build a prototype, and then now I have an implementation. But without governance, there's really no clear path to go from this is state A, this is what we're currently at, to this is my prototype, and this is the prototype or the implementation deployed on mainnet. And this is one of the big reasons why this hasn't worked in Ethereum, and like why Ethereum hasn't changed a lot, because it's like a super opaque story on how do you go from the current version of Ethereum, how do you convince the community to upgrade, how do you convince miners to upgrade. So the first fundamental thesis here is that systems need a way to change itself. If you have and by the way, I don't mean this exclusively. Some may survive without that ability. For some, this may be a feature, right? If you want like true immutability, so let's say you have Bitcoin and you're actually okay with, like you don't want to change. Like this is one of your features where it's like, you promise to the world this will never change. It's a trade-off though, because I can almost guarantee you that Bitcoin will not be the computational layer that everyone in the world uses. It's like, no matter how good our layer 2 solutions become, it's very unlikely that Bitcoin will be the root of trust for the entire world. Because fundamentally, this is like the first ever prototype that we built as a blockchain, and I really hope we don't end up in a state of the world where like the first hacky implementation of something is the thing that runs like the entire decentralized space for the next 300 years. This is not to say that BTC as an asset class, that may survive independently of the chain. So that's the first thesis. The other thesis around governance is also that you want a system, or like governance systems in general, have access to incredibly large pools of capital, right? And it is, right, everyone sort of speaks about DAOs in the blockchain space, and sadly the Ethereum DAO never worked out because of code bugs. But things like Cosmos and Tezos, they're roughly valued at $1 billion each right now. They can easily print, let's say, 10 to 20% inflationary funding a year, so they could spend $200 million each to fund underlying core protocol development if they wanted to. And I think this is a very underappreciated aspect of the capabilities that governance has. Governance is going to become this incredibly large capital allocator where like the governance system itself can say, we really, really want this and we're willing to pay for it. And this hasn't existed in Ethereum either. Like this hasn't existed actually in any existing system. In the existing systems, sort of the way the money came, like the origins of the money that sort of funded a lot of the core devs were either you had foundations that give grants, and this still exists to some day, and it will take time for the protocols to pick up the entire slack there, or that you just said, well, I mean, this is sort of the Bitcoin thing, right? It's like a lot of the core devs still are the people that were very early on Bitcoin, but it's like right now it's very hard for a new team to get like, yeah, we want to do core development on Bitcoin. How do you get funded? No one knows. Well, I guess I'll raise VC. What is VC money? What is the business model for VC money to do Bitcoin core development? Totally unclear. I guess I'll sell to enterprise. How does enterprise use Bitcoin? Well, now I'm not doing core development anymore. So like the entire business model here is sort of with regards to funding is sort of strange. And the second thesis, so these were sort of the first thesis around governance, and the second thesis is protocols need to understand, like, need to provide financial incentives for core development to happen on top of them. So what happens usually right now is that core development is incredibly fork heavy, right? You have a good core dev, you have a good development team, you're much better off by going, well, I know how to build decentralized applications. I know that like the Ethereum community is not going to pay me tons of money to keep extending Ethereum. Well, I guess I'll do an ICO and start selling my token. I'll do my own competing chain. I'll directly compete with Ethereum. This is sort of, for example, like Near protocol is a good example of this, where Near protocol, the actual implementation is super similar to ETH 2.0. And it sort of begs the question, why did they choose to do their own thing? Well, of course, there's the governance thing, but there's also a thing that the financial upside is just much, much larger in building your own thing. To some extent, this may also be a reason why Parity decided not to extend Ethereum, but rather focus on Polkadot, right? It's sort of a much easier incentive structure there. So really, the second thesis here is that protocols need to figure out how to adequately compensate for the opportunity cost that core devs are necessarily taking. Because otherwise, even though you may have non-forking consensus systems, you may if protocols don't figure out how to sort of like get 1,000 people working on core, it's most likely going to be like 1 or 2 teams that are directly funded as a result of the original fundraiser, nothing else. And sort of just to put this into perspective, right? Let's say you're a small team, you want to like do your own little thing, you may, so for example, actually, one good example here could be something like Edgeware, right? Edgeware, like it's using a lot of the code base, it's a relatively small team, it's a lot of the code base from Substrate. Even if that chain is only valued at $50 million, which is nothing, and it's sort of like what other systems exist there that are completely pointless right now, if they took a 10% pre-mine, they will already received more money from like doing this forking behavior of doing a different chain with a different consensus mechanism than Parity has received in its lifetime in terms of Ethereum funding to build the Parity client. So this is sort of interesting, right? And I think the protocols should really start figuring out how to and by the way, this also exists in the real world. I learned about this recently. Google has this project called 120, I think, or it's sort of an internal Google incubator in which they say, well, if some of our employees want to do their own thing and we incentivize them to not leave Google, but they can sort of join the Google internal incubator, build their product, build their ideas within Google, and we provide them a similar financial upside as they would have had in the real world. But as Google, we never have to worry about them competing directly with our business model, so we can sort of harness all this, it's called entrepreneurial spirit, to go into making Google better instead of them going out in the open market, competing for a little while, and then we have to buy them out again. It seems a much saner model, and I think over time, hopefully more and more blockchains will sort of start thinking about this. So yeah, the two theses, we need to incentivize core development to happen in a non-forking behavior, and we need to have clear upgrade path from sort of state A to state B of the world. Because otherwise it's a political nightmare that no one really wants to deal with, figuring out which 3 buttons to push in order to get an opcode changed in the EVM. And sort of the third thing is, on not reinventing the wheel. And this may be very controversial if you're coming from sort of like traditional industries and sort of traditional schooling and like Western schooling, where it's like, oh, you definitely shouldn't copy, you shouldn't cheat of other people, you shouldn't just take their ideas and like start extending them. But I very much come from the open source world, and I just want to reiterate how important this is for the overall development speed, that like there has been about 10 years of research into blockchains and building decentralized applications. There's no reason to reinvent everything from scratch. Like copy, steal, cheat from as many people as possible. Because overall, it just massively increases the speed at which we can develop these systems, right? And one controversial example here could be China, right? If China had gone, well, we don't want to see like how Western people build mobile phones, we'll try to do everything ourselves, this would have taken a lot longer than just saying, let's buy a bunch of mobile phones, reverse engineer how these things work, and then start extending and improving upon the existing design. And I think this is much more the mentality. We're already taking this, but more and more in the blockchain space, it comes up now, like, should we have patents, should we not have patents? It's like, I think it's the wrong approach. Like, you want to be as nimble and as quick as possible and just learn from everyone else that came before you so you can move as fast as possible in order to get us into a usable state. Cool. As sort of the last thing, I'd like to sort of like, I think 6 different topics on like the exciting things that I think most people, if you care about core protocol development, should spend some amount of time on over the next 5 years. Sort of the highest level, the highest leverage things you can do. The first one being interoperability. So currently we live in this sort of very strange world where for some reason when I want to build an application, I have to decide do I want to build it on Ethereum, do I want to build it on Bitcoin? And once you've made the decision, you're very much locked in. It's not that you can easily shift your computation or your assets from one chain to another. This will definitely go away in the next 6 to 12 months, though, with a protocol called IBC that will effectively allow trustless moving of assets across blockchain systems. So, for example, that I could take 1 Bitcoin, I move it into Ethereum, maybe through the Cosmos Hub, and on Ethereum I issue a derivative over this 1 Bitcoin, so I split it up into 10 different tokens. And then I go and move 5 of those different tokens over IBC into Tezos, and then use them in some insurance product or whatever. But generally speaking, over the next sort of 12 months, maybe longer, we'll see that we'll decouple the underlying state machines from the assets they're securing, so that assets can move independently of state machines. The next area being zero-knowledge proofs. And zero-knowledge proofs will be fascinating for 2 main reasons. One of them is computational compression. So let's say I want to write an efficient light client, and things like Tenement consensus have made light clients way easier and way more efficient. But another approach to this is that I say, well, let's take 1,000 headers and let's construct a proof in zero knowledge that those 1,000 headers are correctly linked to each other, and they sort of like, the state transitions happen correctly between them. And so as a light client, I simply get the proof and I verify the proof. Instead of downloading 1,000 headers, I now have a constant-sized proof that I can verify. The other aspect of zero-knowledge proofs will be computational privacy. So how do we build private payment systems? Very similar to Zcash. How do you make them more useful? This is another interesting research question, right? In Zcash, you sort of have to use the blockchain as a messaging layer, which means that right now I have to like effectively run my own full node to scan and like try to decrypt every single transaction to see if I got a payment. Hopefully there are better solutions to this. Like the current state of things isn't great there. So the third area here being proof of stake. And it's important to understand that consensus is not proof of stake. So proof of stake is not a consensus algorithm. Proof of stake is a Sybil resistance mechanism and a mechanism to incentivize economic behavior on a chain. The reason why most people sort of confuse those is because in proof of work, they were effectively the same thing. So in proof of work, there's not much difference. even though technically there's Nakamoto consensus, which is like longest chain, most work consensus, and then there's sort of the actual hashing, which just determines who's allowed to produce the next block. The cool thing about proof of stake, though, it gives us way more degrees of freedom in how we can build and sort of tweak our systems. So all of a sudden we have so much freedom in how we incentivize certain behavior on-chain, how we punish certain behavior. And I think we'll start, sort of over the next 5 years, we'll have to innovate a bunch more to actually maintain this property of permissionless, censorship-resistant, decentralized applications. And so I think this will be fascinating to do, and we should talk to a bunch of economists as well. Next one being consensus. So Goon yesterday talked about Avalanche, and sort of currently with Avalanche there may be 3 different classes of consensus mechanisms: Nakamoto consensus or longest chain consensus, heavy chain consensus, whatever you want to call it, traditional PBFT, so something like tenement consensus, and then now Avalanche. The interesting thing here may be that either we discover a new 4th class of consensus mechanisms, or we figure out good ways to combine them. A good example of why this is a very interesting topic is that I personally think running pure tenement consensus, for example, is very risky, because if more than a third of your validator set goes offline, you all of a sudden have to figure out how to restart that thing. And combining Nakamoto consensus and tenement consensus together so that the Nakamoto consensus is sort of this unsafe fallback mechanism, but that is globally agreed upon, is quite an interesting research direction. And I think Web3 is taking it into that direction with Grandpa. So consensus will be another large area where if I were to get into the space right now and sort of, I'd spend a lot of time on. Next one, scalability. I think this is on everyone's mind anyway, but just generally speaking, how do we scale these systems so we can have more transaction throughput under the same security model? Sort of, how can one validator set, so how can the Tezos validator set, for example, control secure 100,000 transactions a second without giving up the properties of decentralization, where everyone can validate state transitions? And this is by no means solved. Like everyone keeps saying this, like Ethereum and Polkadot are solving this, and they're making good headway on this, but this is by no means final. There's still a lot more work to be done, so like, even if you're new to the space, get into this. And I think the last thing is really governance. And this is, to me, one of the most fascinating things, because so this week we'll be injecting a proposal into Tezos and with binding on-chain governance. And what the result of if the proposal is accepted, the proposal itself modifies the governance mechanism, right? So we have this recursive function over which we can improve our own governance systems, where currently there are no hard limits on sort of how far the quorum can swing in either direction, but the new proposal introduces hard limits. And so all of a sudden you have this, that like it proves that you can change everything about a protocol. Generally speaking as well, here for some reason, most of the blockchain space went like, we know what we're doing with governance. We don't need to talk to people that have done this in academia for 30 years. This is another sort of large thing. Not only copy and learn from other blockchain projects, but also copy and learn from people that are doing this outside of the blockchain context, because they have a tendency to have done this for a way longer time, and they've run into way more problems before. So it's like, we can avoid a lot of our pitfalls if we just like talk to someone that's like slightly more knowledgeable in a specific area. Cool, yeah, thank you very much. This was sort of my super brief talk about core protocol development, why it matters, why it's super important, and most importantly, why I think that actually, if I can leave you with one message here, it's like the systems that figure out some of these problems around how to incentivize core protocol engineering to happen in non-forking behavior on their chain are the systems that are very, very likely to, over time, outpace everyone else. Because instead of all the work going to different systems, you can sort of like focus on one thing and make this one thing better and better over time. And this is really what I hope for. Yeah, you can find me on Twitter or Cryptium Labs on Twitter. We're a bunch of protocol engineers, so if any of what I just said sounds interesting to you, please reach out to me. We're always looking to hire more people. So, thank you very much. Cool. Yes. No questions.